Imagine you are standing on top of mountain, blindfolded, and your goal is to reach the lowest valley. That's exactly what the gradient descent is, a step-by-step process to find the optimal path for the minimum of loss function. And there are three, let's say, different ways to take these steps. This batch gradient descent use the entire dataset for each update. Stable but slow and also resource consumption. If you have, let's say, a small GPU and you will not be able to update load the whole data set into a memory for updating the weights, let's say, for back propagation. And the second one is stochastic gradient descent. Take one sample at time. For instance, if you have 10, let's say, million record, or let's say million image, and it will try to read the first image, do the forward propagation, and update the uh, do the back propagation to update the weights, and then input the next image. It will try to use the newest, let's say, weights, and do the forward propagation, and after that calculating the loss and updating the weight only with one sample. This is stochastic gradient descent. It's faster, of course faster, but noisier. Imagine you have to update every time with each sample the weight. It will not be stable, let's say. And the last one is mini batch gradient descent. It's combining speed and stability. So for instance, you can see I need to update the weight with batch size. Each time it will load, for instance, 5 images, 10 images. This is n, for instance, n samples. And but here's the tricky part: the learning rate, the step size you take on every move. If it's too low, if the learning rate is too low, you will scroll slowly. You'll move. I mean, your movement will be slowly. Maybe even got stuck before reaching the bottom. And if it's too high, you will overshot the valley. Let's say maybe you will move in another direction, and might be, let's see, never converge. And but when it's just the right, you guide smoothly to the minimum with efficiency and precision. The key insight is this: the le- oops, the learning the learning rate is the most critical hyperparameters is ingredient descent. It decides whether your model converges to an optimal solution or fail to learn together. So remember, mastering gradient descent, it's not just about the algorithm. It's about finding the right learning grade. And there are several, let's say, strategies how to improve, how to update the gradient, the learning grade, and we will see this in the next videos. I think that's it. If you like this video, please subscribe into my channel, like the video, and of course, if you have any question, just drop it down in the comment below.